You're driving in a new city, trusting your phone to guide you. Turn right in 200 meters, it says. You follow the instructions without hesitation. But have you ever wondered, how does your phone know exactly where you are? What if GPS suddenly stopped working? How lost would we be? GPS, or Global Positioning System, is a marvel of modern technology. It was originally developed by the US military in the 1970s but is now essential in everyday life. It helps planes land safely, allows farmers to plant crops with pinpoint accuracy, and even tracks lost pets. But how does it actually work? Above us, orbiting about 20,000 kilometers above Earth, is a network of at least 24 satellites constantly circling the planet. At any given time, no matter where you are, at least 4 of these satellites are in the sky above you. Each one carries an atomic clock, an incredibly precise timekeeper that only loses about 1 second every few million years. These satellites constantly send signals that include their exact location and the time the message was sent. When you use GPS on your phone or in a car, your device picks up these signals. Since radio waves travel at the speed of light, the time delay between when the signal was sent and when it arrives at your device allows it to calculate how far away that satellite is. But one satellite alone isn't enough. To understand this, imagine you're somewhere in a city and you only know how far you are from one landmark. That means you're somewhere on a circle around it. If you add a second landmark, now you're at one of 2 possible points where those circles overlap. With a third landmark, you can pinpoint your exact location. GPS works the same way, except instead of landmarks, it uses satellites in space. This process is called trilateration. Your GPS device locks onto signals from at least 3 satellites to determine your latitude and longitude. A 4th satellite helps calculate altitude, making GPS useful for pilots, hikers, and even submarines navigating underwater by tracking their last known surface position. But there's a challenge. These satellites are moving at around 14,000 kilometers per hour and they orbit in space where gravity is weaker than on Earth. According to Einstein's theory of relativity, their high speed slows time slightly, while the weaker gravity speeds it up. These effects are tiny, just microseconds, but if not corrected, they would throw GPS readings off by several kilometers every day. To prevent this, scientists have programmed the system to adjust for relativity, keeping your location accurate. Despite its precision, GPS isn't perfect. Signals can be blocked by buildings, trees, or tunnels. That's why, in cities, many smartphones combine GPS with cell tower and Wi-Fi data to refine location tracking. This is also why GPS can sometimes show you on the wrong street or take a few seconds to catch up when you turn. Another common misunderstanding is that GPS works through the internet. In reality, GPS signals come directly from satellites. Your phone doesn't need Wi-Fi or mobile data to receive them. However, apps that display maps or calculate traffic conditions do use the internet to load additional details. Today, GPS isn't the only global navigation system. Russia has GLONASS, Europe has Galileo, and China has Beidou. Many modern devices use a mix of these systems for even greater accuracy. The future of GPS includes even more advanced satellites, better accuracy, and possibly new ways of tracking locations without relying on signals from space. So, the next time you follow directions on your phone, remember that it's not just a simple app guiding you. It's an entire system of satellites, atomic clocks, and physics working together to keep you on course. But here's something to think about. What if for just one day GPS completely stopped working? How much of our modern world would come to a halt?
Got a question about how something really works? Drop it in the comments and we might cover your topic in our next video.